Salam and good day. So for today's lecture, we are going to learn on the last interrupt. Previously, we learned about two interrupts, which are the RB0 external interrupt and RB4 to RB7 external interrupt. For today's lecture, we are going to concentrate to the interrupt, which is they call it the timer 0 counter overflow interrupt. So on the previous lecture, you also learned about the timer 0. So I assume that you guys know how to calculate and what is the function of a timer 0. For example, it can generate the what kind of waveforms uniformly, and you can also measure how long the time taken for the timer 0 when it's counting, right? I mean, you can measure the time based on the formula that you learn in the class. Okay, for this one, right, for the interrupt, it's just like the same like the RB0 and RB4 changes, but the thing is right now this is using the internal clock, where it will be based on the timer and also the clock, right? So the timer 0 is the register again, and this is an 8 bit that you learned from previously from the class. So timer 0 interrupt is an 8 bit timer that counts from 0 to 255. Remember that one, right? Because of it has 8 bits size. 1 2 3 4 1 2 3 4. So the lowest one will be this one, and the highest one will be 1 1 1 1 1 1 1, right? So this is a 0, this is 255. So counts from 0 to 55 and generates an interrupt whenever it overflows. So this portion you need to understand. It will generate the interrupt when it overflows. This will be the condition where 1 1 1 1 1 1 1 go back to 0. Right, so means that the register is already full, so it's like an overflow situation, so then it will reset back to 0. So for this particular moment, right, this one going to this one again, so this is a condition, they call it overflow, and this is where the interrupt happens. Okay, so that will be the most important thing when the interrupt happens. So when you run a timer 0, right, when you run this one, it will start to count 1 2 3 accordingly to the instruction cycle. Remember that one times is going here, one step, it will take one instruction cycle, right? So it's around 4 clock cycle. That will be the case lah. For a 20 megahertz clocks will be around, this one is around 200 in a second. So that will be the case, all right? So every time it's step up, so you're going to have this type of time. You can calculate based on the formula. All right, so let's go to look at the related registers. So again, to enable the interrupt, you must know how to set your interrupt control register, which is they call it incon. So for this case, we are going to learn, we're going to set up for the timer 0. So let's look at this one. So this one you have to turn on 1, and you also have to turn on this one also 1. This is timer 0 overflow interrupt enable bit. So this is 1 and this is 0. The rest you don't really care here. Like for this one, external interrupt, you don't care, you don't want to use this one. This is also used, and the rest of the flag are all 0, right? So remember that every time the interrupt happens, it must have its pair of the flag. So for this case, the flag will be this one, bit number 2. By default is 0, right? By default is 0. So you see that when interrupt happens, timer 0 register has overflowed condition just now. So interrupt had happened and it will turn to 1. And then you must clear again in the software to make sure the next process can have the interrupt process happen again. Okay, so this one again to show that this is a pair where you need to set up, right? So you just know that you have to set up here 1 1, the rest are all 0. Okay, the next one on the register. So remember, for timer 0, you need to set up the option register. They call it option reg. So this is the register that you are going to set the prescaler for the timing of the timer 0. Remember that what is the prescaler is something that can divide more on the frequency. So you're going to look at the finally the period, okay, the t, how long the what you call that, how long the time you can, how long you can calculate based on how many stepping on the timer 0 cycle, and what are the prescaler given or set. So I always normally use this one. It's much easier to look at this one because this is based on the instruction cycle, which is around 200 nanosecond for a 20 megahertz clock, and prescaler is based on this one, timer 0 rate. So you are going to set which one is going to be that prescaler, and timer 0 cycle is the counting from the beginning of timer 0 cycle. For example, it start from 0, then it stop at 255. You have to count all up to 255. All right, for the case of, okay, for the case of you don't want to use the timer 0 start from 0, yes, you can do it, where you can set up, for example, timer 0 start is equivalent to 100. You can do that, no problem. You start from 100, so means that it's going to step up to 255. So the stepping is only for this particular timeline. So 0 to 100 is not calculated. So just make sure that you have to know that every time you have to insert this value in your program. So if you do not put correctly, then you may have this process 255 go back to 00. So I may just have some example on this one. So let's look at how the interrupt happens here. All right. To do this one, right, you have to go back to your macro C. So this is your macro C again. So of course, when you are using the interrupt, you must have your own function interrupt. All right, this one, and then you have this one. Right. So the interrupt must happen here. Okay, so we can start. So you want to make wave the signal go up and down, and then we can look at the results maybe from the oscilloscope LED. So we can start here. I want to use port B. So let's look at the port here. Right, for example here, this is a port B. So I want to set up this port as the output up and down. So let's start trace B is equivalent to 0, all output, and then I'm going to set my incon, right? Incon register is equivalent 0B 100 101. The rest are all 0. This is to set the timer 0 interrupt. Let's double check that one. Double check 10100. So that will be the setting. And then you are going to use the option right to set the prescaler, right? Is equivalent to 0B. So the first one must be 1 because this is the pull up resistor. If I'm RB4, I think, if I'm not mistaken. So 1 must be here, right? And then you are going to use, for example, we are going to use which one? Look here. So I'm trying to put the first one here 000, right? The last 3 is 0, so it means that all will be 0. Only this one port B pull up is you have to set 1. You are going to disable that one. So the rest are all 0, 1, 0, 0. All right, option right is equal to 0B 1, 0, 0, 0, 0. So this is the setting for the incon and the option right for the timer 0. So next one, I'm going to start my timer at what? Timer 0 is equivalent to 0. That will be my first value in timer 0. So I'm writing down a value 0 in timer 0. Okay, next one, I'm going to put up my port B. Port B is equivalent to 0 times FF. Right, this is should be like this way. And then you have the while one loop. Okay. Okay, let's run this one first, whether it's correct or not. Bill, is there any problem? Okay, no syntax problem. So far, we are already set the condition. So what we're going to do in the interrupt. So right now, right, the port B is giving a 5 volt signal, right? High state. So I just want to do one interrupt. What happened after this condition overflow? It will go down here. So means that if the timer 0, once you start the program, right, the timer 0 will count 1, 2, 3, 4 up to 255, and after 255 overflow happen, interrupt happen, so it must go here and do something. So I want to pull down the port B signals. Let's try to do that one. Port B is equivalent to 0. So this is the first case, right? So remember that once the timer 0 complete to 55 and then you go back to 0, interrupt happen, it will go here. One of the flag for the interrupt for timer 0 is only 1. You have to reset back inside here. Okay, you must reset here, means that in con is equivalent to 0 times 2 0. This is like equivalent to 0b 0010 and 0000. So the incon now is going to be changed like this. Right, so you're setting up this one. Okay, so you're changing the flag just now from this one 1. What happened just now? If interrupt happens, the flag, okay, the flag like this one just now. The flag here will what you call that? The flag here will be flag here. The timer 0 interrupt flag. One timer 0 just has overflow and must be declared in software. So right now you're going to have this one, and then you have to clear this one. So let's check what happened here. If this one complete, and then we'll go here back, wait for the timer 0 to overflow again, and then go up once the interrupt happen, and it should be high low in a uniform manner. So let's try to look at the results. Okay. So the latest one is correct. This one, right? Then we're going to run this one. So I'm going to look at the debug here, your digital oscilloscope. Oh, something is not correct. Sorry. This is not port B, sorry, this is going to be all 0. Means that after this one it's going to be all 0 all the time. So you have to do the invert. So the command will be this one, port B. Right, so it means that right now initial is this one, and then you go interrupt, invert, and then go down here, and then go up back, invert all the time. So if I put just now 0 all the while, means that once it go up here, the port B all now 0, and then interrupt hammer all 0, means all 0. So my code just now is wrong, so I can do the invert. Every time it go to interrupt, you will invert. Alright, so just build this one, and then you run this one. Now you can see the results from here. So let's try to look at the measurement here. Okay, you can click the cursor here and try to look at this one may be around 100 microsecond. Okay, so every time one interrupt is 100 microseconds. So is it correct or not? So double check. Let's go and double check. Okay, the case will be, for this case, let's look at the command here. Right now, the timer is from 0 to 255, right? So you have the step cycles from 0 to 55. The prescaler is given here is 2. Right, 0, 0, 0 is 2. Right, prescaler is 2. The cycle for timer 0 is 255. And then based on this one, you can just get the value of the time. So 1 inside second is equivalent to 200 second. and then times prescaler is 2 times 255. Let's double check this one. Okay, 200 nanosecond here, right, times 2 times 255, around 102. So you can go here to get the value. This is 102, so shift here, this is 0.1. okay, this is not going to be, so this is 102 micro. So let's look at the proteus again. This is, yeah, 102 microseconds, which is correct, right? Roughly that one. Okay, let's try another one, another measurement. Okay, let's change the prescale to maybe 255. So you're going to change the last three all 0 to 1. Option right is here, 111. All right, so we're going to use the same one here, and then we just build this one. Okay, then you can just run this one again and look at the result. Now you can have to play with this one. Okay, this one is correct already. So around 13 milliseconds. So is it correct or not? So based on these calculations, the calculation 200 seconds correct, 255 is also the same thing, and you are going to times 256 because the prescaler have been changed. 256. All right, so 200 nanoseconds times 256 times 255. Then you have this one, right? Just now, correct or not? This is 13 milliseconds. This is 13 milliseconds. It's the same thing. Right, this is the part of it, correct. So I have changed this one just now because in the lecture just now I told you guys you can write not 0, you can write another value which is maybe not 0. So you can try to put the value here, not 0. You can start maybe at 100. Okay, you have start this one means that you start with 100 and it will count 101, 102, 103 up to 255, and then it will go back to 0. Okay, and do the interrupt. It will go here. So means that if you want to change this one, you have to put your timer again. You have to insert your timer 0 is equivalent also to 100. So you are going to set back the value 100 and it's going to do counting from that one. Okay, for this case, then your counter will start at 100, not 0. Instead of 0, it will start from 100 and it will count. So means in between 100 to 255, you have to take the difference. Okay, for example here, let's just try to calculate first. So let's look at this one. So if this is not going to be 255 anymore, right? So this is going to be like 255 minus 100. So this is going to be only 155. So let's try to check whether the theory is correct or not. Okay, so you can run. So now it's 7.75 milliseconds. So let's check the results based on the new value that we put here in the calculator. Okay, 200 nanoseconds is same thing, 200 nano times 256 times 155. Yeah, 7.9. So it means that 7.9 milli. You can see here is around that figure, right? Yeah. So this is just some error. So more or less it's nearly the same like from the theory. So the timer 0 is the one that you can put not only from 0. So you can also put the value uh, from 0 to 255. So it means that from here, right, you can do some task over here, not this one. This is just to show, right? Your task can be part of anything. Like for example, you want to turn on something, right? And then you can do it by predictly this one. Okay, so this is the case. So here I'm going to show you guys later how you can control and use the interrupt to control the servo motor, right? So this is part of it. So the thing is right now, this interrupt is using the timer 0 values, and you also very consistent in times because it's actually based on the external internal clock and the what I call it, the prescaler, the frequency that it has. Okay, so thank you very much. We are going to look at the next video for the servo.